let's do some multiplication with base 10 blocks. Now, base 10 blocks, you say, it's been a long time since we've used those. Do you remember what they are? Well, I'm sure this picture will remind you. There's the hundreds block, 10 rows, 10 in each row. 10 times 10 is 100. There's the 10 stick or the 10 rod. It's got 10 units in it, and then there's the single unit. We're not going to use this exact one because I want to be able to color on top of it, and I can't color on top of yellow as well. So we're going to use some ones that are white, but these are the ones that we have in our classroom. We have the yellow plastic one. Well, multiplying with base 10 blocks is a little different. There's some good concepts behind it, and that's why we're going to do it, because it's a good way to illustrate multiplication and what multiplication is. Say we want to multiply 23 times 17. Well, we're going to use 10 rods to do that. So 23. So the first thing I'm going to do is I'm going to mark off 23 cubes on this side. This is 10, so I can just do it all at once. 10 and 10 is 20, and we want 23. So 1, 2, 3. On this side, we want to show 17. Well, we want to break it apart into 10 plus 7. So here's 10. Then here's 1, 2, 3, 4, 5, 6, 7. Okay, so we've got 10, 20, 23. We've got 17. So let's just do this step by step. 10 times 10 is 100. So I've got this hundreds block, and I want to fill the whole thing in. So I'm just going to try my best to fill it in here. So it's not too messy. It's a little messy. Huh? So there's 10 times 10 is 100. 10 times 10 is 100. Okay, now we have 10 times 3. So what I'm going to do is I'm going to count 3 over, 1, 2, 3, and I'm going to go straight down, because 10 times 3 is 3 groups of 10, and that's exactly what I have here, 3 groups of 10. Now I have 10 times 7, so I'm just going to stretch this line for the 7 across, and then I'm going to, shade all these in, because I have 7 10s. I have 10 times 7 again, so I'm going to stretch that 7 across and shade all these in, because it's a row of 10 times 7, so 7 times 10. And this one is the one that's a little easy to get confused, but let's count. It's 3, so I'm going to go over 3, and then it's 7, and so I'm going to just block off what 3 times 7. Not too bad, a few white spots here and there, but for our purposes for multiplication, that is just fine. Let's add these up now. This is 100. 10 times 10. Oh, let's go something a little darker. 10 times 10 is 100. 10 times 10 is 100. 100. 3 times 10, 30. 10 times 7, 70, and we did exactly the same thing here, and 3 times 7 is 21. Now let's add these up. Now, I could do it in my head, I could write them out. You do what is most efficient for you. Right off, I know that 100 plus 100 is 200, so I'm going to go ahead and just skip writing it out. I'm just going to write 200. I know that 30 plus 70 is another 100. So I'm going to just check those off. And I'll do the 70 and the 21 separate. Okay, so I'm adding them up. 7 and 2 is 9. 2 and 1 is 3. And there you have it. 23 times 17 is 391, and we did it using base 10 blocks. Let's try another one. This time we have 35 times 24. So we're going to do the same thing. We're going to show 35. Well, let me put that time sign there. 35 on the top. And I like to show the largest number on the top, the smallest number on the side. Because of the commutative property of multiplication, it doesn't matter. I just think it's easier to always do it the same way. And so 35. Oh, that's a little bit hard to see. Let me choose something else. Okay, 10, 20, 30. That's still a little hard to see, isn't it? 31, 32, 33, 34, 35. I know why I have the opacity turned down too much. So 35. Just go over these to make it a little bit clearer. Down this side, we want to do 24. So 10, 20, 21, 22, 23, 24. 10 times 10 is 100. 10 times 10 is 100. 10 times 10 is 100. 5 times 10, I'm going to see where my 5 is, and I'm just going to stretch it down so that I'm actually shading in 50. 5 columns, 10 in each column. I'm going to switch to a larger size again to make it a little bit faster. 10 times 10 is 100. Oh, it's a little too big to do it neatly. 10 times 10 is 100. 10 times 10 is 100. 5 times 10, 50, 10, 20, 30, 40, 50. Now we have 10 times 4. So I'm going to see where that 4 is. 1, 2, 3, 4. And I'm just going to go straight across. And I still have 10 times 4, so I'm going to do the same thing. Go straight across. 10 times 4. Go straight across. And this one is 5 times 4. So I'm going down 4 and over 5. And see how they do line up. Okay, that's not too bad. I think that's definitely doable. And let's add them up. We have 100 here, 100, 100, 50, 100, 100, 100, and this was 50 again. And this was 40, 10, 4 rows of 10, 4 rows of 10, and now we have 20. So let's add these up over here. I'm just going to count up the hundreds. 1, 2, 3, 4, 5, 6, 600. 50 and 50 is 100. 40, 80, 120. And let's get that 20 in there. So 0, 2, 4, 6, 7, 8. 840. Now, it's not practical to do this for your multiplication problems all the time. This was to get the idea that you can do it with base 10 blocks, and it just is a conceptual way of showing our partial products, breaking down numbers and multiplying them, using the things that we do know we can do with, because we can multiply 10 by 10, we can multiply 5 by 4. So it's breaking bigger numbers into pieces to make it easier to solve, using what we know to solve what we don't know. I hope this was helpful.